Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
This class, let us study about periodicity in valence and oxidation state. Periodicity in valence and oxidation state. Here periodicity means we are studying about a regular repetition of the valence and oxidation state. Periodicity means regular repetition, that is repetition of properties in regular intervals. What is valency or valence? Before studying what is valency, let's study what is valence electrons. What is the meaning of valence electrons? Valence shell means outermost electronic shell. The electrons present in that outermost electronic shell is called valence electrons. So we can say valence electrons are number of electrons in outermost electronic shell. It is number of electrons present in the valence shell means outermost electronic shell. This outermost electronic shell is called as valence shell, which we represent as nth shell. Here n stands for highest principal quantum number. So, electrons present in nth shell or valence shell are called as valence electrons. Whether valence electrons and valence are same? No, they are different. Then what is the meaning of valence? This valence is also called as valency. Valence or valency are same. What is valence or valency? Valence or valency may be equal to number of valence electrons, and they are equal to number of valence electron for group 1, group 2, group 13 and group 14. Group 15 onwards, valence is number of valence electrons or 8 minus valence electron. What is that 8? 8 is the electrons which leads to stable electronic configuration. 8 means octet. So, valence is defined as either number of valence electrons or 8 minus number of valence electrons. It is number of valence electrons up to group 14 elements. Group 14 onwards, it is either number of valence electron or 8 minus number of valence electrons. Now, let's take up the group 1, 2 and group 13 to 18 elements. Means group 1 and 2 are S block elements. Group 13 to 18 are the elements belonging to P block. For these elements, let us write valence. These elements are together called as representative elements, or these elements are also called as main group elements, because their properties vary in a regular trend. Group 1 to S block, group 13 to 18 P block, they are known as representative elements or main group elements. Now let us write the valence for these elements. Group and valence. Let's consider group 1, 2, then 13th group, 14th group, 15th group, 16th, 17th and 18th. Let me write for group 13th element, 14th, 15th, 16th, 17th and 18th group. For these elements, first let us write the electronic configuration. After that, let us find the valence. Once if we write electronic configuration, it will be easy to find the valence. For the group 1 elements, the electronic configuration is NS1. Outermost configuration we are writing, that is outer electronic configuration. For the group 2, it is NS2. For group 13, NS2 NP1. For the group 14, NS2 NP2. For the group 15, it's NS2 NP3. For the group 16, NS2 NP4. For the group 17, NS2 NP5. For the group 18, NS2 NP6. These are the outer electronic configurations. So for these elements, let us find the valence. We know what is the formula to calculate valence, or what is meant by valence. Valence is either number of outer electrons or 8 minus number of outer electrons. Here, if number of outer electrons are up to 4 means up to group 14, it is number of valence electrons only. So, up to group 14 let's take up. NS1 means number of valence electron is 1, hence valence is 1. For the group 2, outer electrons are 2 only, so valence is 2. For the group 13, 2 electrons in NS orbital, 1 electron in NP orbital, so valence is 3. For the group 14, 2 electrons are there in NS orbital, 2 are in NP, so valence is 4. Then group 15 onwards, it is number of valence electron and 8 minus valence electron. Group 15 configuration is NS to NP3. So number of valence electrons are 5. One more valence is 8 minus 5. That is 8 minus number of valence electron. 8 minus 5 is 3. So there are 2 valences, 5 and 3. For the group 16, number of valence electrons are 6. And 8 minus valence electron means 8 minus 6, that is 2. So valence for the group 16 is 6 and 2. For the group 17, number of valence electrons are 7 and 8 minus 7, that is 1. For the group 18, 8 is valence and 8 minus 8 means 0. So group 1 to 13, 14 have only one valence. Group 15 onwards, there are the valences which is equal to number of valence electron or 8 minus valence electron. What about D block and F block elements? These D block and F block elements have many valences, because nowadays instead of valence, oxidation state is a term used. For these, there are many oxidation states or valences, so we say they have variable valence. Why do they have variable valence? Why? Because the ionization enthalpy of the d electrons and the other electrons in the same shell is almost same. Since there is no much difference in ionization enthalpy of the valence electrons and the penultimate and antipenultimate electrons, the variable valence is found. What is meant by penultimate and antipenultimate electrons? Penultimate electrons means electrons present in one shell inner to valence shell. ಅಂದರೆ ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ಲಿನ ಒಳಗಡೆ ಇರುವ ಶೆಲ್ಲಿನ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಅದಕ್ಕಿಂತ ಇನ್ನೊಂದು ಶೆಲ್ ಒಳಗಡೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ಅದು ಆ್ಯಂಟಿ ಪೆನಲ್ಟಿಮೇಟ್. ನೋಡ್ಕೊಳ್ಳಿ, ಈಗ ನೀವು ನ್ಯೂಕ್ಲಿಯಸ್ ಸೆಂಟ್ರಲ್ಲಿ ತಗೊಂಡ್ರೆ ಅದರ ಸುತ್ತ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿವಾಲ್ವ್ ಆಗ್ತವೆ ಬೇರೆ ಬೇರೆ ಶೆಲ್ಲಲ್ಲಿ. ಔಟರ್ಮೋಸ್ಟ್ ಶೆಲ್ಲನ್ನು ವೇಲೆನ್ಸ್ ಶೆಲ್ ಹೇಳೋದು. ಒಂದು ಶೆಲ್ ಒಳಗಡೆ ಪೆನಲ್ಟಿಮೇಟ್ ಶೆಲ್, ಅದಕ್ಕಿಂತ ಒಂದು ಶೆಲ್ ಒಳಗಡೆ ಆಂಟಿ ಪೆನಲ್ಟಿಮೇಟ್ ಶೆಲ್. ಇಲ್ಲಿರುವ ಎಸ್ ಪಿ ಡಿ ಎಫ್ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿಯಲ್ಲಿ ಜಾಸ್ತಿ ಡಿಫ್ರೆನ್ಸ್ ಇರೋದಿಲ್ಲ. ಹಾಗಾಗಿ ಇಲ್ಲಿ ವೇರಿಯೇಬಲ್ ವೇಲೆನ್ಸ್ ಕಂಡುಬರ್ತದೆ. ಸ್ಟೂಡೆಂಟ್ಸ್, ನವಡೇಸ್ instead of valence, the term oxidation state is used. So let's find what is oxidation state and what is the meaning of it. Oxidation state is the charge acquired by an atom in a compound. So it is the charge. Charge means it may be positive charge or negative, or it may be zero also. Charge possessed by an atom in a compound. Due to electronegativity difference. So based on electronegativity difference of the bonded atoms, the charge is given for the bonded atoms, and that charge is called the oxidation state. Oxidation state is variable for an element. It is variable for an atom of element. That means in a different compounds, same element will have different oxidation state. But valence is not like that. Valence for a particular atom is same. Oxidation state varies for the same element in different compounds. Valence is just a number. We do not write positive or negative sign for the valence. But oxidation state is having the sign before the number. It may be a positive sign or negative sign. Generally, oxidation state is determined based on how many electrons are donated by an atom, or how many electrons are gained by an atom, or how many electrons are shared between the two bonded atoms. So charge is told based on electrons donated, electrons accepted, or electrons shared between the atoms. Let us take example. let's consider oxidation state of the elements in the given compound. Let's take compounds. I'll take two compounds. One is Na2O, another one is O2F2. I'll take these two compounds. In compound Na2O, I have two elements, sodium and oxygen. In O2F2, again I have two elements, oxygen and fluorine. We know along the period electronegativity differs. Down the group also it differs. Sodium is group 1 element, oxygen is group 16 element, fluorine is group 17 element. So here sodium is group 1 element, oxygen group 16 element, fluorine group 17 element. Means when we move from group 1 to 17, electronegativity increases. So if I consider electronegativity of these elements, among these fluorine is more electronegative than oxygen than sodium. Fluorine is more electronegative than oxygen than sodium. That means fluorine has tendency to gain electron. More electronegative is more non-metallic. Non-metallic means gaining electrons. Less electronegativity means tendency to donate electron. Students, one which donates electron gets a positive charge. One which accepts electron gets a negative charge. If an atom donates one electron, it gets plus 1 charge. If an atom donates 2 electrons, it gets a plus 2 charge. If an atom accepts 1 electron, charge on it is minus 1. If an atom gains 2 electron, charge on it is minus 2. So charge is positive if electrons are lost. Charge is negative if electrons are gained. Always less electronegative atom loses electron, more electronegative atom gains electron. That means in Na2O, sodium loses electron, oxygen gains electron. How many electrons are lost? How many electrons are gained? Depends upon the electronic configuration. If I write electronic configuration of sodium, atomic number is 11, so configuration is 1s2, 2s2, 2p6, 3s1. Electronic configuration of oxygen with atomic number 8 is 1s2, 2s2, 2p4. Electronic configuration of a fluorine whose atomic number is 9 is 1s2, 2s2, 2p5. Just observe one thing. Just look at the outermost configuration of all. Sodium outermost configuration is 3s1, oxygen 2s2, 2p4, fluorine 2s2, 2p5. When they can become stable? They become stable when they get octet configuration. Means they have 8 electrons in the outermost electronic shell. Only when they get 8 electrons in the outermost shell, they will become very stable. So in order to get that 8 electrons, they may donate electrons or they may take electrons. Look at sodium. 3s1 is outermost configuration. Oxygen 2s2, 2p4. Fluorine 2s2, 2p5. If sodium loses one electron, it becomes stable. So sodium loses one electron. Oxygen needs 2 electrons. At that time it will be 2s2 2p6, means 8 electron. So in sodium oxide, sodium will have oxidation state +1, because if it loses one electron, it gets a stable 2s2 2p6 configuration. Hence sodium loses one electron. How many sodium are there? 2. That means 2 sodium lose totally 2 electrons. Those 2 electrons are gained by oxygen. Hence its configuration becomes a 2s2 2p6. So oxygen gains 2 electron, hence oxidation state is -2. You take O2F2. In this, fluorine is more electronegative than oxygen. Means oxygen donates electron, fluorine takes electron. Look at here. How many oxygen are there? 2 oxygen. 2 oxygen lose 1 electron each. They donate 1 electron each. Why? Because fluorine requirement is only 1 electron. Look at here. 2s2 2p5 is a configuration. Fluorine needs 1 electron. Oxygen has tendency to donate 2 electrons, but fluorine says 1 is sufficient for me. 1 is sufficient, because if I get 1 electron, I will become stable by getting 2s2 2p6 configuration. This is what fluorine says. So oxygen says, okay, I will give only 1 electron. So this oxygen gives 1 electron to 1 fluorine. Another oxygen also gives 1 electron to 1 fluorine. So in O2F2, oxygen has a +1 oxidation state. Fluorine takes 1 electron, hence -1. There are 2 fluorine. Each fluorine takes 1 electron. Each oxygen gives 1 electron. So oxidation state of oxygen is +1 here. For fluorine -1. Just compare the oxidation state of oxygen. In sodium oxide it is -2. In O2F2 it is +1. That is what I said. It is variable for an atom. For an atom, oxidation state is not constant, but valence is constant. So difference between valence and oxidation state is, valence is number of valence electron or 8 minus valence electron. Oxidation state is charge possessed by an atom. Valence is a number without a sign. Oxidation state is always number with the sign. Valence is the same for a particular element. Oxidation state varies from one compound to another. So this is all about periodicity in valence and oxidation state. In the coming class, let's discuss about few more concepts related to this particular chapter. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.